I want to introduce part 2 of the project by telling you a story about a research project that I was involved with when I was a very new teacher, a high school biology teacher, and I was lucky enough to be involved in research that had a direct impact on my own teaching practices. So I'm telling you this story because part 2 of the class focuses on quantitative research methods or positivist methods. And more specifically, it's going to introduce pre-experimental designs, experimental designs, and quasi-experimental designs. And I'm going to tell you a story about a research project that would probably be classified best as a quasi-experimental design. So back when I was a secondary life science teacher, mostly high school biology, I started off my teaching career, my very first job, pretty much doing to my students really what was done unto me. What was done unto me as a college science major, but also what was done unto me as a student in high school. I went into biology as a subject area because it was one of my favorite classes in high school, and it's always been something that I've been really interested in and passionate about. And so when I got my first teaching job and I was teaching biology, I did what was done to me, and that was what we call a more didactic approach, very content focused. So the first thing I did was organize the content that I wanted to present to my students, and I thought I had really great stories, really great lectures. I put together some really good notes that my students had to copy because I wrote lots of stuff on the board because that was what was done to me. And I had some really good films to back up some of the things that I was going to be talking about because science films were really interesting to me, and I hope they'd be interesting to my students. And we did some lab experiences, really more verification experiences where I would be teaching about a particular topic and then we go do a lab activity that sort of verified some of the specific things that we were learning about. Well, at the same time I was doing this, I was taking some graduate classes in teaching biology, and I was so lucky to end up having a professor who was investigating something that was coined at the time the learning cycle approach. And it was sort of a problem-based learning approach that was being implemented at the time that I was a teacher. It was new, but it was very common for science teachers to try more problem-solving approaches. And first of all, it was very unique to me because I had never experienced that kind of teaching in any of the classes that I had taken before that graduate class, and certainly not anything that I had taught. Now, I'll just give you a little bit of a background on what the learning cycle looks like. There are different types of learning cycles, but essentially students are immersed in an experience where they make a lot of observations and they end up observing naturally occurring phenomena. And they try and organize their observations and they look at what they're observing and they search for patterns or they search for questions they have about the things that they're observing. And then they may or may not consider possible answers to any questions that they have, and then they can design some investigation to help try and answer their questions. And there's different ways that they could design those investigations. But the main thing is that designing the investigations was what, as a science teacher, I was trying to get them to learn how to do. So in the broad sense, I was trying to get them to learn how to apply scientific reasoning to the quest of answering questions, or at least beginning to answer questions that they had about the world around them, and specifically, because I was a biology teacher, about the life science experience. So again, that's very, very different than having students sit down in a seat, having me stand up or any teacher stand up and then lecture on a specific body of content. So I was really intrigued by this method, but I also had a lot of questions about it. Foremost, how could I do this and ensure that my students still learned some of the content that I knew that I would be responsible for having them sort of test over some of the content? Because at the time, we didn't really have any end-of-course tests that focused on scientific reasoning. It mostly focused on a lot of content, a lot of like labeling diagrams of things like an animal cell or a plant cell or a system, like the digestive system and or that kind of thing. So I was very curious about that. Now, one of the things that my professor taught me was that you have to sort of put aside the idea that content is going to drive the experience, because your ultimate goal, is to help students learn how to think or reason more formally, as opposed to concrete reasoning that they all sort of came into the class doing. And as I said earlier, I was very lucky because my professor at the time was putting together a research project in which he was going to test the differences in student learning based on the learning cycle approach or the more traditional didactic content-driven approach. And so in this study, students were identified. It was actually whole classes or intact classes that were identified as groups of subjects from different participating schools. The schools were selected because their student demographics was very similar, and classes were randomly assigned to either one treatment, the learning cycle approach, or the more traditional didactic approach. But the students themselves were not randomly assigned to those classes. And that's why the model itself could be considered a quasi-experimental approach, because really there wasn't really fundamentally random assignment of individual subjects, just intact classes. So for a whole semester, teachers addressed the same broad scope of content, teaching one way or the other. And then students went through those experiences, and at the end of the semester, they were given a post-test, and in which content was measured, scientific reasoning skills were measured, and other variables of interest were measured as well. And those included things like attitudes towards science, and that would be a student variable, and also attitudes towards teaching, and that would be a teacher variable. And in those attitudes for teachers, things like design and implementation concerns were also measured. So that was the really cool study that I got involved with. And I won't go into great detail about the results because it was one study of many. But I will say that there is enough evidence from a collection of studies to suggest that the learning cycle approach does in fact help promote scientific reasoning skills or scientific thinking skills, both in a general sense and also transferring it to other scenarios or other situations. Also, attitudes towards science were much more positive for the students who got to experience the learning cycle approach. And so that was an experience that I had, and since a number of you are special ed teachers, I will follow it up with one more little tiny story that's related to this. So I taught high school biology, but it was at a junior high school, and so I also taught 8th grade life science. Life science was taught in the 8th grade in the school district that I worked at. And one day, a teacher came to me, and I learned, it was a very large school, first of all, let me tell you. We had 1,500 7th, 8th, and 9th graders. So that's a pretty big school, and for 3 grades. And I didn't really know all the teachers, and I was a new teacher. And one day, a teacher came to me, and she asked and she asked if she could borrow a skeleton that I had, a human skeleton model. And so I said, oh, absolutely, sure, how come? And she said, well, I'm teaching that chapter in the book that we have on the skeletal system, and so I'd like to have a model to talk a little bit about it. And I didn't even know that there were other teachers teaching life science. I also didn't know she was a special ed teacher. And at the school that I was at that time, the special ed teachers taught in self-contained classrooms. So her students, she had students all day long, one group of students, and she was the teacher for all the subjects. And so I told her, yeah, I'll bring the skeleton to your classroom. They were down in the basement. That also adds to the whole kind of inequity of the situation. And so I took the skeleton downstairs and I took it into her classroom, and I noticed that she was using the same books that I was using, but her students were sitting at their desks and they were reading through the books or through the chapter. That was what they were doing for science. My students, all, by the way, at that same time were out mapping some wilderness areas near campus to try and figure out ways to measure the amount of different types of living organisms in a particular community and in a sample of the community, because we were going to get into a discussion about why biological communities are structured the way they are. Why are there always more plants than animals in terms of mass? And anyway, that's what we were doing, because I was doing the learning cycle approach, and they were out doing stuff, right? But down in the basement in the special ed class, the teacher was having their students read from the text. Again, a very didactic approach. And I remember thinking at the time, you know, I can guarantee you that the students in that special ed class would have a more successful experience learning important science-related things if they were out in the wilderness mapping areas and trying to figure out how to measure biomass and other things. And I'm only bringing this up because, in addition to the approach that I used, having more, like cultivating better attitudes towards science and better thinking skills, I also know that it would have supported that special ed teacher, or at least her students, a lot better. And I know that that teacher probably never learned about the learning cycle approach and probably never once had it modeled for her. So I became a real fan of that approach, and the evidence suggests that it's a very effective approach for helping students, and I would suggest all students learn some really important things. So that's one of the experiences I had when I was a young researcher working in the field, also teaching at the same time, and that was an example of a quantitative research approach that we used to try and support claims of efficacy regarding that method of teaching. Okay, so you are going to be learning about the different quantitative approaches, and then in project number 2, you are going to apply some of the fundamental concepts and ideas of quantitative research methods to 3 parts of a project. Now, the content of the projects focus on some variables related to learning that are included in the understanding how we learn text. And those 3 fundamental areas include perception, attention, and memory. So in part 1 of the project, you're going to, after reading the chapters that address those 3 aspects of learning, I'm going to ask you to reflect on some of the ways that you personally have learned or not learned based on the strategies and principles presented in the readings associated with perception, attention, and memory and their effect on learning. So I'm going to have you consider your own personal examples for part one. Now then in part two, I'm going to have you, I'm going to assign you a research study, a quantitative research study that you're going to examine, and you're going to analyze it based on the fundamental components of most types of quantitative research studies. So you're going to analyze it and you're going to identify some of the characteristics of that, including, and I'll read from my list, what the research problem is, what the hypotheses were as described in the study, what type of research design was employed, what the independent variable was, or there might be multiple independent variables, what the dependent variables were, and what any extraneous variables were included and controlled in the study design. Also, strategies for minimizing threats to validity. Those are all things you're going to learn about in the information for the class. What data were collected in the study, how the data were analyzed, and also what the general results were. So that's part two, is you're gonna identify those characteristics of the research study. And then in part three, I'm gonna have you identify a research study, and then I'm gonna have you use AI to analyze it in the same way you had to do in part two. But this time AI is going to evaluate, you're gonna ask AI to do what you did in part two. And then you're going to look at what AI did, and you're going to just examine what the results of the AI analysis, and you're going to try to identify how accurate it was. And so, so those are three related parts. And again, they're related to some of the fundamental learning concepts that are presented in the in the understanding how people learn text. So I hope you enjoy this week. It's really one of the fundamentals of educational research, and hopefully the project will help you understand through the application process some of the fundamental concepts that are presented in part two. So good luck, and I hope you enjoy it.